Hello and welcome to Week 2, Unit 5 of the Open SAP course Touch IoT with SAP Leonardo. My name is Pascal Raubricht and I'm a product owner on the Asset Intelligence Network team at SAP. In previous units you were already told about the SAP Leonardo IoT portfolio pillars. One of those pillars is the Connected Asset pillar. A few applications are included in the Connected Asset story. One of those is the SAP Asset Intelligence Network. I will start off with a simple story flow to create a simple understanding of what SAP AN is all about. So imagine we have three manufacturers, two suppliers, manufacturer C providing a motor and manufacturer B providing a sensor to a bigger manufacturer producing and manufacturing compressors. As of now, and that's the status quo, those suppliers have of course backend systems where they store data about all the assets they produce. Once they ship those parts to the manufacturer A, they extract the data from their backend systems and send it to manufacturer A, either as letter, email, fax, or maybe even phone calls where they just tell the specifics about those parts and components. Manufacturer A in turn, they usually have whole departments receiving the data, putting it into their backend systems, where they store all the data of their assets and also of the supplied parts and components from other manufacturers. In the end, once the compressor is done and manufactured, it's shipped to the operator, and with the asset itself, also documentation will be shipped to it, to the operator. Here again, we talk about letters, emails, fax, and other semi-automatic and digital documentation. The operator, if it's a bigger operator, he has a backend system as well. And one of those backend systems might be a maintenance system in order to maintain the asset and keep it alive. In order to do those maintenance activities, the operator usually needs data from the supplier. Data on how to maintain the asset, data on what the asset is all about, specifics like dimensions, size, everything you need to maintain the asset properly. This data, as mentioned, comes in a semi-digital way, letters, emails, and is then put by one of the colleagues at the operating company into the backend system. All of those steps are not integrated. So we always have someone pulling data from somewhere and sending it to someone else. This produces a lot of effort and quality gets lost throughout the supply chain. So in the end, what arrives at the operator might not be the best data you could get. And if the operator is not putting effort in to maintain those data into his backend, he might run into risk later on when maintaining the asset. And this was the handover stage, when the asset is shipped to the operator. Even once arrived at the operator, we face a lot of problems and struggles with the master data, but also with transactional data which you need to assess what already happened to an asset. So here you can see all the phases of an asset lifecycle, and usually different departments work on each of those phases. So maybe the commissioning, the installation of an asset is done by one team, and the maintenance is done by other teams. And sometimes they don't talk to each other. And even more important, the systems they each use are different. So the documentations you can see here at the bottom might reside in different systems. And they might be even redundant in some systems. So this is one problem the operator is facing throughout the asset lifecycle. Another problem, all the documents here, that's the status quo of the handover. So the update of document, that's a big challenge for operating companies to get the most up-to-date data and then find the old data points to replace it with the new ones. To summarize, we have two challenges: non-integrated systems, manual effort to extract the data, to send it to someone else and put it there back in the systems. Second problem, we have those vast variety of systems within a company, whether it's the operating company or a service providing company. We had one big operating company painting that picture, and I think that depicts the entire problem pretty well. So they might have all the documentation but it's just chaotic. They have a lot of documents, 300 pages of PDF from manufacturers, maybe even booklets, and they have it somewhere. Basement full of documentation, which they at one point in time need, but when they need it, it's tough to find it and get it. So what we are trying to achieve with the Asset Intelligence Network, we want to get rid of the silos, rid of the semi-automatic way of sending data. We want to introduce one platform, so that every asset in the world is residing in our SAP Asset Intelligence Network platform. So here in that example, the compressor, or what we call digital twin of the compressor, would reside in SAP EAN, as well as all the components of that compressor. The advantage of this is that the sub-suppliers, manufacturer C, manufacturer B, they can provide that information directly to EAN. Manufacturer A only needs to provide information about that bigger asset, the compressor as such. The components, the sensor and the motor or the engine, the data to those two components will be still made available by manufacturer C and manufacturer B. And they only need to integrate to one system. So manufacturer B, they don't have to integrate to each and every manufacturer system anymore, each of their customer systems. So it's one platform where all of their customers are on. Then on the other side, the operator side, they can now finally connect their backend system to only one platform. Before that, it was hardly possible because each and every manufacturer or supplier in that case had their own manufacturer portal. Connecting to 1,000 manufacturer portals was not efficient, and that's the reason why no one did it, and why there's so much manual effort required still. So now operating companies can connect their backend system to our SAP EAN and fetch the data directly into their systems in order to execute maintenance activities, in order to get an insight into the data of an asset and also transactional data. In conjunction with products like SAP Predictive Maintenance and Service or SAP Connected Goods, we can display the data in SAP EAN and not only make it available for that one customer who owns those systems and products, but only to other stakeholders like service providers of this customer, in order for them to have a better insight to action when it comes to those assets. Another point here, it's not only about having all the assets in one platform, in one cloud, it's also about having the same structure for each asset. So no matter who produces a compressor, the operator will find a subset of data to be identical no matter who produces those compressors. So if they have 2-3 compressors from 2 or 3 different manufacturers, they will find a subset of data which is identical, and that makes it easier for them to compare and really make an informed decision on which compressor to use for which situation. So that's the first part of putting the asset as such, the object, into EAN. The second part is to have one single point of entry, an access point of entry to all the information. So here, throughout the life cycle, within an operating company, we want to either persist all the data in EAN, and here we mainly talk about master data, documentation, etc., or we want to create a pointer to those information, especially when we talk about transactional data, work orders, so someone performing a work on an asset, we want to make it transparent here in EAN, or sensor data, so that you can really have a look at your health status for that asset in EAN using other products like PDMS and Connected Goods. So we want to be the single point of entry and the single point of truth for that asset, no matter who's contributing data. As of now, we only talked about manufacturer and operator. There are lots of other roles. And the most obvious and prominent role, that's the role of the service provider. So here it's especially important for that service provider to know all the asset data, which wasn't the case maybe before because they had their own system where they maintained their own work orders and activities they performed on the asset, and the operator might have another system. Now you can bring both systems together and create one unified view on that asset. Just a few challenges on top of the challenges I've just shown you before we go into the system. The operator challenge, they have a lot of manufacturers and suppliers. And they provide data in different formats. If they're lucky, they can grab those data points and information from those manufacturer portals. This, however, happens manually. So someone is writing down a login, logging in, downloading a data point or data document, let's say. Outdated information on models, because it's kind of cumbersome to go to that manufacturer portal, finding the right login details, the right URL. They might often use old documentation. Yeah? They might be just okay to go in the basement and search for that 10 years old document, rather than logging into a manufacturer portal and using the most up-to-date one. And it's difficult to compare equipment. Every manufacturer is having his own way on providing data. So it's hard for a site engineer, for a planner, to really compare and cross-compare. Most frequently, they have their own database to those kind of comparisons. And many manual steps to adding equipment to a system. With AAN, we might get rid of it and make it obsolete at all, because the manufacturer is creating the equipment in the first place and then transferring that equipment to the operating company. The manufacturer on the other side has similar challenges. He needs to maintain a lot of communication channels to a lot of customers. Yeah? And each customer might prefer the one or the other way. With AAN, that's a unified platform. The manufacturer only has to push the information once, like a service bulletin, and then it's published to all the operating companies using a certain model of his. And getting operation information from the different assets and install-based knowledge. This was lacking so far. Manufacturers trying to come up with their own platform to fetch sensor data, etc. Usually operating companies, they have a hard time connecting their sensors to those platforms. Now that the operating companies can use their own historians, connect the sensor to those historians, and then make that historian transparent in some extent to other companies like the manufacturer. Manufacturers will now get an insight into the install base and really the health of their assets. Last slide before we go into the system. AAN is built on 3 pillars. The most important pillar is content. Similar to LinkedIn, where LinkedIn is all about people, AAN is all about assets. And as you might imagine, a LinkedIn with no content and no one posting anything or writing anyone would be worthless. No one would access it anymore. And that's why content also for AAN is vital and important. You can already create a lot of value just having content in. So we're looking into operating companies who want to use AAN as a consolidation platform for all their equipment. Another added value comes from the network effect. If you don't only have your equipment in AAN, but also the models, the type of equipment provided by the manufacturer and all the content related to those models, this would create additional value. And that's why the network is also very important. So in LinkedIn, if you would be the only one posting for yourself, you might not do that. Applications, we want to make use of the content, the master data, but also the sensor and transactional data. We want to build apps on top of it. We already did so, and I'm going to show you in the system, but we also welcome any other partners, customers, to create their own applications on top of AAN. Since we are built on top of the SAP Cloud Platform, you can go ahead and create your own extension or entirely new application, which is using and consuming AAN data and might connect to other systems to enrich those data with your own data. Now I would show you the system. So what you see here is the SAP Asset Intelligence Network. As it is running on the SAP Cloud Platform, it's a browser-based solution. So the only thing you need is a browser in order to access SAP AAN. Here you see quite a lot of, we call them tiles or applications. We have 3 main applications, and those are the models, the equipment, and the locations. I will jump right into the equipment application to show you what a maintenance planner, a service technician, and also on the manufacturer side, the manufacturer would work with. So the first thing you see opening the equipment application is the list of all of your equipments. So in this demo system we have 170 equipments. You could of course filter by your location. You might not be interested in a plant far away from you. You might just be interested in the plant you're responsible for. So let's go into one equipment. And this is a pump. Mega CPK CKD pump. And what you see here is all the information around that pump and that specific asset, starting with model information. So this specific equipment is inheriting all the information from Mega CPK QKD. That's the type of asset it is. Comparable maybe to the BMW 3, and that red BMW 3, that's your equipment, inheriting every information from the general BMW 3 model. So here we see model information, we see who's the manufacturer of that equipment, SAP manufacturer. We also see from which standard it is inherited from. So that manufacturer, SAP manufacturer, created a model based on a certain subclass. It should be the pump subclass. The advantage here is that in that subclass there's a set of attributes, let's say 20 attributes, which are common for every manufacturer. So no matter which pump you're looking at, those attributes are identical. Talking about attributes, this is what you can see here. You have equipment-specific attributes and generic model attributes, which you might still need in order to perform some work activities. Then here in the installation information, you have information about the serial number, about the stakeholders, who is involved, who can see your equipment, who can work with it, like the service provider, for example. And you have information about the installation location, which you can also see clicking on that hierarchy button here. You can see that it's built in Helgoland, which is in Germany. And here you have a geographical representation on a map. Lifecycle information, you can see what's your model, when is it expiring in the sense of order stop, etc. Very important for plant or discipline managers who are planning the next plant shutdown. They want to know what's the next model and which models do I have to procure. Structure and parts, you can see which subcomponents are built into your equipment. And those subcomponents are also serialized and instantiated. So you know exactly what's built in. It's a form of track and trace for your equipment. Spare parts, you have a 3D representation. You can also use our Visual Enterprise Viewer, which is built in. You can zoom in, you can select a part, you know what that part number is in order to procure it in case it's broken or has to be replaced. So in here you see the 3D file. You can zoom, you can hide certain parts in order to look behind the curtain, see what's built in, and then you can procure as a next step. Documentation, all the model documentation and equipment-specific documentation are maintained and provided here. So that's everything maybe the maintenance worker knows or has to know in order to perform his activity. Instructions. So of course the manufacturer still has the possibility to provide a PDF instruction. But on the other hand, he could also provide a visual instruction, which might be easier to consume for the technician in the end, doing a maintenance job. So what you see here in a moment is an animated, we call it a VDS file, Visual Enterprise file, or a CAD drawing, where you can see step by step what has to be performed in order to do, in that case, a bearing replacement. So here if I click on play all, you see step by step what has to happen without reading anything. So here we have efficiency gains. So for customer service, we integrated to Hybris Cloud for Service, and we fetch the tickets, and we can also create service tickets. If you have to assign someone from outside your company, you can create a service ticket, and they come and fix it. And the trigger point could be AN. Timeline, you can see what happens to the equipment to its digital twin, just document updates, etc., but also what happens in real life to that asset. In monitoring, you can see measuring points, and if you connected it to any sensor system like predictive maintenance and services or connected goods, you can get the data in here. You can get a first glance of the current reading of the last 20 to 50 readings. If you want to know more, then we have the possibility to create an extension, which I can show you here. That's specific for, in that case, a valve. We just put it in here, where you can see the lubrication level for that valve. You can also see which work orders are performed in the past, have been performed, and then you can proactively send someone to apply some grease to that valve. That's the very brief walkthrough of SAP AAN.